Hello, welcome to this video for the 2022 Scholarship Calculus of 2022 for question 2C. So this is a follow-up from question B. So consider a different triangle which has side lengths that form a geometric sequence of common ratio of r. If alpha is the angle opposite to the side that's neither shortest nor the longest, what is the maximum possible value of alpha? We should interpret our answer. Alright, so this question I find it really helpful just to draw a really quick sketch of the triangle first to know what we're talking about. So just see we have a triangle here, and we will have a side with r squared, and r cubed. And we know that alpha is the angle that's opposite of the side that's neither the longest or the shortest. So we're going to be putting it, so alpha would be this angle here. Alright, so in this case, we should probably try to make an equation for alpha in terms of r, and then we should solve this equation to find the maximum possible alpha for this triangle. So in this case, we can just use the cosine formula. So in this case, we have a cosine formula would be c squared equals to a squared plus b squared minus 2ab cos of c. And if we plug in our values, we'll have r squared whole squared equals to r to the power 3 squared plus r squared minus 2 times of r cubed times of r cos of alpha. So let's just simplify this a little bit. So we have r to the power 4 equals to r to the power 6 plus r squared minus 2r to the power 4 cos of alpha. So we can divide through by r to the power of 2. So we have r squared equals to r to the power 4 plus 1 minus 2r squared cos of alpha. So we can rearrange here for alpha. So we can say that r to the power 4 plus 1 minus r squared equals to 2r squared cos of alpha. So cos of alpha equals to 1/2 of r squared plus 1 over r squared, and do quick maths here. So we have 1 over r squared minus 1. And therefore we have alpha equals to inverse cos of 1/2 of r squared plus 1 over r squared minus 1. And we can just find the derivative of this equation and then make equal to 0 in order to find the maximum the r value that's going to give us the maximum angle for alpha. So let's find the derivative. So in this case, we know that if we have cos of inverse of x, if we have y equals to cos inverse of x, then we know that dy on dx equals to 1 over square root of 1 minus x squared, negative 1. So in this case, we'll have d alpha over dr, that equals to negative 1 over square root of 1 minus of everything inside the bracket squared. So 1/2 of r squared plus 1 over r squared minus 1 whole squared, multiplied by the derivative of the inner function. So remember the chain rule, so we need to multiply by the derivative of 1/2 of r squared plus 1 over r squared minus 1. So we're going to be multiplying by 1/2 times of 2r minus 2 over r cubed. And this is going to be setting equal to 0. So if we set this equal to 0, then we know that the denominator doesn't really matter since we just multiply both sides by the denominator. We're going to have negative 1/2 times of 2r minus 2 over r cubed equals to 0. And we're just going to multiply both sides by negative 1/2. So then we'll have, divide both sides by negative 1/2. Then we'll have 2r minus 2 over r cubed equals 0. And therefore 2r equals to 2 over r cubed. And if we multiply both sides by r cubed, we'll have 2r to the power 4 equals to 2, and r to the power 4 equals to 1. And we can just solve this simply for r equals to plus or minus 1. But clearly, geometrically, negative 1 doesn't make sense. So geometrically, r equals negative 1 makes no sense. So r equals to 1. And if r equals to 1, then we'll have, in this case, we will have cos of alpha equals to what we had above there. So 1/2 of r squared, which is 1 plus 1 over 1, which is 2, minus 1 is 1. So we have 1 here. So equals to 1/2. So therefore alpha equals to pi on 3. So in terms of interpreting our answer, so if we know that alpha is pi on 3, then what does that mean for our triangle? That means if r is 1, then 1 times of 1 times of 1, all of them are going to be the same length of, even though the common ratio, if the common ratio is 1, they're all the same length. Therefore, we have 3 sides of the same length. So therefore, in this case, we're going to be having the case where we have the equilateral triangle. So in this case, what we're going to be having is just an equilateral triangle with side length 1. Sorry. So what we have here is just equilateral triangle of side length 1. And in this case, we know that the alpha angle value is pi on 3 or 60 degrees. So in this case, interpreting an answer just means, in this case, we see that the maximum alpha will occur if we have the equilateral triangle, so all sides of length 1, and all of them are of equal length. So that's it for this question, and hope to see you all in question 3a.